let's do some scale and indirect measurement problems. So they say use the scale diagram to the right to determine. I think this is the scale diagram that they're talking. It's really above the question. And they want to determine, let's see, the length of the helicopter. When they say the scale diagram, notice this helicopter looks pretty small. I don't know how big your screen is, but it looks a couple of maybe 1 or 2 inches, depending on what resolution you're watching this video on. But they're saying this helicopter is much bigger than that. They're saying just this little distance right here, just that little distance, that little white box there, that's actually a foot on the real helicopter. So what they're able to do is draw a small version of the helicopter and essentially give us a ruler to tell us that that little distance is equivalent to a foot. And this whole distance right here, that whole distance right there is equivalent to 1, 2, 3, 4, 5, 6, 7 feet. Did I get that right? 1, 2, 3, 4, 5, 6, 7. So this thing is equal to 7 feet. So given that, let's try to answer their questions. So the first one, the length of the helicopter. So that's from cabin to tail, is that distance right there. Let's see how many of these things it is. So if I take that right there, let me see if I can copy and paste that. So if I copy it, then I paste it, there's 1 right there. 1. Edit, paste. 2 right there. Then edit, paste. And then we get not quite 3. Almost 3, but not quite. We get about that far. So it looks like about 2. So this right here is 7 feet. That right there is another 7 feet. And I know that because that is 7 feet according to the scale. And then this looks like we got about that far. So it looks like this is maybe another 5 feet if I were to estimate. Actually, if we went to go all the way to the end of the tail, if we went to the end of here, it actually looks like another 7 feet. We actually complete 3 7 feet. So I would say that part A, I would go to 27 feet. Sorry, not 27, 21 feet. 7 feet times 3 is equal to 21 feet. I'd go with part 1. Because if you go all the way to this tippy of the rear rotor of the right there, then you're going to get 21. You're going to get 3 of these lengths. Let's do part B. The height of the helicopter, floor to rotors. So from here, from floor to rotors. Well, I'll go from down here to the rotors. They might be talking about this floor, but who knows? I think this will. So what is this distance right here in feet? What is that distance? So we could just eyeball a little bit. They didn't give us a vertical scale. We could just, this scale looks like about that high. It looks about that high. So that would be about 7 feet. So let me copy and paste that. So let me copy it. Let me paste it. So that would be 7 feet right there. And then if I were to do another one, we're getting about another half of 7 feet. So that would be another 3.5 feet. So I would say this is 7 right there. And then we get about 3.5. So 7 plus 3.5 is 10.5 feet. The length of one main rotor. And I think the main rotor, they're talking about this length right there. That length right there. That is the length of one main rotor, or actually this length right here. That is the length of one main rotor. And let's compare it to this scale over here. So let's compare it. That's 7 feet. So let's copy it and then let's paste it. So that is, oh no, you can't. I lost it. So let me copy it. Let me copy and then paste. So that's one length. So we want one rear rotor. So that's 7 feet right there. 7 feet right there. And then we could do another one. The important thing is to get the idea of it. You don't have to get the exact measurement. We're not about to go out there and build a helicopter. So what is this length? We have 7 feet. And then we have 1, 2, 3, about another 4 feet. So I would go with part C. I'd go with 11 feet for one rotor. If we're getting to see this actually head on. Maybe it's a little bit longer if it's at an angle. But that gives us our general idea. Actually, it looks a little bit longer than that. But yeah, as long as you understand how I'm using the scale as the main thing. The width of the cabin. So here, that's the cabin width right there. This distance. That distance right there is the cabin width. And if we compare it to this right here, we already said that this right here is 7 feet, roughly. So edit, copy, edit, paste. So if that is 7 feet, that looks like about the width of the cabin. That's a good estimate. So the width of the cabin, I would say, is 7 feet. And then finally, the diameter of the rear rotor system. The rear rotor system is this right here. That is the rear rotor system. So if we were to copy and paste our 7-foot length, actually, let me copy and paste the actual ruler. So this is our actual ruler. So how long is the rear rotor system? Let's look at our roller. It looks like 1, 2, 3, 4 feet is my best estimate. So I'd say the diameter of the rear rotor system is 4 feet. So you might have already known how to do this, but now you have a good sense. Look, this is telling us that this little distance on the picture is actually equivalent to a foot, and you just compare it to the actual picture, and you know how big the actual helicopter is. That's all that's going on there. Let's do another scale and indirect measurement problem. So it says on a Sunday morning, the shadow of the Empire State Building is 600 feet long. At the same time, the shadow of a yardstick, which is 3 feet long, is 1 foot 5 1/4 inches. How high is the Empire State Building? So we could say height of Empire to length of shadow. So length of shadow of Empire should be equal to taking the length of a yardstick. So height of yardstick. I'm assuming that they're pointing up the yardstick like a skyscraper. Height of yardstick divided by length of shadow of yardstick. Now, this problem looks a little bit hairier because we have feet here, and then we have 1 foot 5 1/4 inches, and you do everything in inches and do everything in feet. And the interesting thing is here, you can look at the units. As long as we calculate this in feet, and we calculate this in feet down here, these units are going to cancel out. If you have, x feet divided by 600 feet in this case, the feet are going to cancel out. You'll have a unitless quantity. So it's really just going to be a pure ratio. Same thing here. You could do it in feet, or you could do it in inches. And you could actually do this in feet and do this side in inches, because you get feet divided by feet. The feet cancel out. The inches cancel out. So they stay unitless. So it actually becomes a lot easier when you can keep the right side in inches and you can keep the left side in feet. So let's say the height of the Empire State Building is x. So we could say x feet over the length of the shadow. The shadow of the Empire State Building is 600 feet over 600 feet is equal to the length of a yardstick standing up, or the height of a yardstick. Let's do it in inches. 3 feet long is 36 inches. 36 inches. And I want to show you that the units work out. 36 inches divided by the length of its shadow. 1 foot 5 1/4 inches. What's that? 1 foot is 12 inches. 12 plus 5 1/4 is 17 1/4, or 17.25 inches. And notice, the units cancel out. Feet divided by feet, inches divided by inches. So they just become pure ratios. X over 600 is equal to 36 over 17.25. The reason why I could use feet here and inches here is because the units cancel out. I want to make that very, very, very clear. Now we can just cross multiply, which is essentially just multiplying both sides of the equation by 600 and 17.25. So 17.25 times x, 17.25 times x is going to be equal to 36 times 600 times 600. And then we can divide both sides by 17.25. Divide both sides by 17.25. So x is equal to 36 times 600 over 17.25. And let's get the calculator out. So x is equal to 36 times 600 divided by 17.25 is equal to 1252.2. Let's just round it. So x is equal to 1252.2 feet, which is almost a quarter of a mile. So the Empire State Building is pretty high. But this was pretty neat because this is something that you could actually do. You could actually measure the shadow of a skyscraper, and then you could actually measure the shadow of a yardstick. And then doing that, you can actually figure out the height of a skyscraper, which is pretty neat because otherwise, if you didn't know how to do this math, you'd have to get into a helicopter and drop a huge, it would be a much harder thing to do. So hopefully you found that pretty interesting.